Hello. Machine learning has become incredibly popular. In this series, I will use the book Hands-on Machine Learning with Scikit-Learn, Keras, and TensorFlow as my primary guide, sharing key concepts, practical insights, and everything I learned along the way. Whether you are new to machine learning or looking to brush up your skills, I hope this journey will help you gain valuable knowledge. Let's dive in and explore machine learning together using this book. So, what is machine learning? Let's start with a definition. Machine learning is a field of study that gives computers the ability to learn without explicitly programmed. Let's say if we want to build a spam filter program. Writing programs to catch individual cases is impossible. No such algorithm can enumerate the spam emails entirely. The spam filter should be based on words or combination of words to predict whether the email is spam or not. In a real-world implementation, spam filter is a typical machine learning program. The program learns from a huge amount of emails, also called the training set. Based on the existing data, it can make predictions on new emails. There are a few cases that machine learning is great for. First, there are lots of cases or rules. Second, there's no good solution with traditional approach. Machine learning probably can help find a solution. Third, get insights about complex program and large amount of data. There are 4 types of machine learning systems. Supervised learning. When training the algorithm, training data has to include labels. Label means the value of given data. For example, you need to label the spam or non-spam email when you want to train the spam filter model. Second, unsupervised learning. The training set is unlabeled. The anomaly detection is a common use case for unsupervised learning, such as credit card fraud detection or detecting outliers in training sets. The system is trained on lots of normal data. It can learn the common characteristics of the data. Like shown in the graph, similar data can be clustered together. When anomaly data comes in, the system can detect. Unsupervised learning can help discovering interesting relationships between attributes. If you want to learn some pattern about your data, try to test it on unsupervised learning. Third, semi-supervised learning. The system trained on partial labeled data, like the iPhone photo feature. It can recognize different people in your photos and cluster them together as the same person to make an album. If you label the person, it knows these people in the future photos. Fourth, reinforcement learning. The agent in the learning system constantly perform actions and get a reward or penalty in return. The end goal is to maximize reward. Like Google AlphaGo, the program is a good example of reinforcement learning. It learns how to win the game by analyzing millions of games. Also, ChatGPT is trained on reinforcement learning. There is a second way to categorize machine learning system, offline learning or batch learning. The model is trained offline. After it is trained, the model is deployed to production without learning anymore. Online training, system constantly learning new data and updating parameters inside the model, such as stock market prediction or weather forecast. There is a third way to categorize machine learning system, instance-based versus model-based learning. Instant-based learning, also known as memory-based learning or lazy learning, uses learned examples and generalizes to new instance by using the similarity measurement. Like shown in the graph, the new instance would be classified as a triangle based on the similarity measurements. Model-based learning, building model from examples and using model to make predictions, like shown in the graph. Let's move to an example to briefly learn the model-based machine learning workflow. The data we are going to use is GDP per capita versus life satisfaction. Let's load the data into memory and check the first few rows. If we want to build a model, it is good to visualize the data first. Let's use the package and plot the data first. Here's the Python code to create the image and see the trend. People who make more money tend to be happier. This is kind of universal rule. Let's use linear regression to fit the model. After training the model, we can use it to make new predictions. We can also use the instance-based learning, replacing linear regression model to k-nearest neighbor regression, and see the test result. Is k-nearest neighbor regression a machine learning model? If it is a model, why it is instance-based learning? The answer is that the k-nearest neighbor algorithm is not model-based. It classifies or predicts new data points based on their similarity to existing data points. Let's use the trained model and make the same prediction. The results of two predictions are pretty similar. We just went through a typical machine learning project. Study the data, select the model, train it on the train set by minimize the cost function. Finally, we can use it to predict the new cases. This is a machine learning appetizer project. The main entry will be shown in the later of this book. There are many challenges when working with machine learning. Let's dive deep into each of them. The main challenges of machine learning. First, inefficient quantity of training data. Microsoft researchers published a paper in 2001. It illustrated that data matters more than algorithms for complex problems. As you can see, high-quantity training data is very important for machine learning. Different models ended up pretty good results after feeding large amounts of data. However, it is not easy to get extra training data. Second, non-representative training data or poor quality data. If we use the outlier to train the machine learning model, it won't generalize well for the new instance. In the real world, we need to get rid of sampling biases and outliers to properly train the model. Third, irrelevant features. Machine learning systems should be trained on relevant features or attributes. Feature selection and feature extraction are two common approaches. Feature selections means selecting the most useful features to train the model. Feature extraction means combining existing features to produce a more useful one. 4. Overfitting the data. Let's change the model to polynomial. High-degree polynomial can fit the most training data very well, but it definitely doesn't generalize to new instances. The prediction can be horrible. Complex models such as neural networks can detect very subtle changes. Sampling noise or outliers can be detected by the complex models. The result of using complex model can be overfitting and cause bad predictions. There are several ways to avoid overfitting. 1. Choose a simple model with less parameters. Using linear regression instead of polynomial for GDP per capita prediction. Second, reduce the number of attributes in the training data. Third, constrain the model. Fourth, gather more training data. 5. Remove outliers and sample bias. Let's talk more about constrain the model. This procedure is called regularization. For linear regression in GDP per capita, there are two parameters. The model can change the intersection with y-axis as well as the slope of the model to fit the data. By restricting either one of these, the model becomes less flexible to fit the data. The regularization forces the linear regression model to have a smaller slope. Normally, the regularization is controlled by the hyperparameter. The larger hyperparameter are, the more restriction added to the model. Tuning hyperparameter is an important part of machine learning. 5. Underfitting the data. There are three potential solutions to address the underfitting. First, select a more complex model. Second, add more features into the system. Third, reduce the constraint, such as reduce the hyperparameters to make the model flexible. In the real world, we can't just train the model and start to use it in production. Sometimes, the model can perform very badly on new instance. Due to this fact, we need to evaluate how the model performs on new instance before the release. One option is to splitting the data into training set and test set. Training model on training set. Test how model performs on test set. The error rate on the test set is called generalization error. By doing this, we can see how well our trained model performs on the data never seen before. Let's say we have selected the best model which has the lowest generalization error on the test set, but the model might overfit the data. How to apply some hyperparameters to avoid overfitting? Remember that hyperparameters prevent overfitting the data by making the model less flexible. A common solution is called handout validation. By taking part of training sets out for evaluation model performance. This part is also called validation set or development set or dev set. Here is how it works. Train model with different hyperparameters on reduced training set. Select model performs best on validation set. Retrain model on entire training set. Then evaluate the final model on the test set to get the generalization error. The cross-validation essentially uses the above method. Instead, it separates training sets into different validation sets. By averaging out all evaluation on the validation set, we can get a more accurate measurement of the model performance. However, it needs more training time. At the last, let me mention the no free lunch theory, NFL. Famous paper published in 1996. David Walport demonstrated that if you make absolutely no assumptions about the data, then there is no reason to prefer one model over the other. For some datasets, linear model is the best. However, other datasets, neural networks are the best. The best way to find out which model is the best is to evaluate all of them. In a real application development, you need to make certain assumptions about the data and choose a reasonable model based on those assumptions. Let's wrap this up. Lots of fundamental concepts introduced in this chapter. I hope you learned something and see you next time.